Good afternoon, everyone. Welcome to the Wet Season Outlook for 2021 webinar. For those of us joining us for the first time, welcome. And for anyone who's joined us for our webinars before, welcome back. Today, our experts will be giving you an in-depth look at the upcoming wet season for tropical Australia, including the monsoon onset, the tropical cyclone and severe weather outlooks, and the current state of water resources across the north. My name is Jordan Peters, and I'll be your moderator today. I'm joined by Claire, who will be producing today's webinar. Together, we will help make the webinar as interactive as possible. But before we start, may I ask for your attention as we cover off some housekeeping items. With the current situation as it is in Australia, this webinar will be conducted from our respective homes. Please bear this in mind as we may encounter some technical issues during the broadcast. Our broadcast will run for 60 minutes today, with plenty of time allocated for questions. This webinar is also being recorded and the video will be shared with you via email. For first-time webinar attendees, please see some helpful tips on your screen. Most importantly, please note the chat box where you can send through your questions or feedback for the presenters. Please use this and not the Q&A box to send your questions to us during the session, and we will answer as many as possible during the allocated breaks. It's the speech bubble button on the right of your screen. The icon will turn blue once it's on. If you want to test it out, you can feel free to tell us your name and where you're dialing in from. And finally, I'm delighted to introduce you to our presenters. From the Bureau, we have Greg Browning and Dean Molyneux. I hope I said that correctly. Greg has worked at the Bureau of Meteorology as a weather forecaster and more recently as a climatologist. While he has a broad knowledge of meteorology, his specialization is in weather and climatology, having worked at all three of the Bureau's tropical regions, including 10 years in Darwin. Dean has worked at the Bureau of Meteorology's water program for 12 years. He primarily works on national water accounts, which looks at water availability and water use in key regions around Australia, including important agricultural areas across Northern Australia. Welcome, guys. So we have a packed hour for you today, including what is the wet season, monsoon basics, what happened last wet season, what are we expecting this wet season, and the potential impacts and severe weather risks. There's a lot to get into, so let's not keep you waiting any longer and get straight to Greg. He'll start us off with an overview of the upcoming months. But don't forget, you can send us a question at any time in the chat function and we'll answer it in the upcoming breaks. All yours, Greg. Greg, I think you're on mute, mate.
Sorry about that. We'll try again. So just a quick executive summary in case you've got to scoot off early. These were pretty much the take-home statements for Wet Season Outlook 2020-21. So above average rainfall. So the map you can see on the right-hand side is the chance of above median rainfall, blue colours indicating above average. So good chance of above average rainfall across pretty much all of Northern Australia. The map below is maximum temperatures, the same sort of theory. This time red colours indicate high likelihood of above median or above average. And you can see that there's a lot of white and not really a strong signal there. So average to below average daytime temperatures. A few of the other things that are pretty important is we're in a climate state that means there's a good chance that we will see an early start to the monsoon onset. So that's the widespread rains across parts of Northern Australia. And also as a result of that climate state that we're in, which is something we will spend a bit of time talking about, good possibility of average to above average number of tropical cyclones and tropical lows across Northern Australia this season. So with that, we'll get into the presentation proper. So we'll just have a quick rundown on just the basics of what is a wet season, how it compares with a dry season across Northern Australia. Then within the wet season, we have a few sort of different phases. One of them is called the build-up, and then we also have the monsoon. But the monsoon is not just the monsoon the whole time. It sort of waxes and wanes. We have bursts and we have break periods. So we'll just go through a few of these definitions and basic concepts. So this is a map showing the main climate influences that affect Northern Australia from year to year. And in particular, this is looking at what a classic picture of a wet season type climate pattern goes. And the main features that we need to look at, if we look towards the top of the map and those arrows coming down from further north of Australia, is those winds coming from the northwest. And they're indicative of a monsoon flow, and they're the winds that bring the really big rains across northern Australia. So they feed into a monsoon trough, which develops over northern Australia, and that's the time when we are likely to see widespread rainfall and also likely to see tropical cyclones develop along that monsoon trough. We go further south, another strong feature of the Northern Hemisphere is the change in the trade winds. So those winds move a bit further south. They dominate Northern Australia during the dry season, but during the wet season, they're pushed further south and they don't have so much of an influence. And then also up on the top, there's some bigger climate drivers as well, and we'll talk about them as well. So up the top right, I mentioned the El Nino Southern Oscillation, and that's sort of the main driver that we'll talk about because that's going to be a big factor in the coming months across Northern Australia. We have the Indian Ocean Dipole on the left-hand side of that map. Not so much of a player this season. We had a very strong positive Indian Ocean Dipole last year, which led to really dry conditions, but this year it looks like to be neutral and so not much of an influence. And then we have another thing that people in the tropics may have heard of called a Madden-Julian Oscillation, and that's a pulse of weather that moves around the globe and influences Australia every month or so during the wet season. And when it's nearby, that's often when we see the really active periods of the monsoon. We see a pickup in tropical cyclone and tropical low development, and we often see the periods of really heavy rainfall. Okay, so looking at the wet season and what phases there are in the wet season. So the wet season, by definition, over Northern Australia is pretty much based on calendar dates. So starts at 1st of October and goes right through to the end of April. Obviously, things don't go from dry to wet just from the end of September into October. So we go through a bit of a transition period. And over parts of Northern Australia, that transition period is often called the build-up. And so we go from a change from very dry conditions with not too much deep cloud or thunderstorm activity to a gradual pickup in humidity, shower and thunderstorm activity becoming a little bit more active, but it's usually quite isolated at this stage. And it's not then until we really get well into the wet season, usually towards the end of December and even beyond, depending on which part of Northern Australia you're in, that we see really widespread heavy rainfall. So that picture on the right is what, it looks more like when the monsoon kicks in, and that's really widespread rainfall, and that's when the really heavy rains occur over Northern Australia. So putting that all together, as I said, the wet season goes from October through to April. The build-up goes through the first few months. So in parts of far north Australia, we may see an end to the build-up by the end of December. And that's characterised by high humidity. It's still very hot. There's not widespread activity, but you do start to see those thunderstorms happen. And then it's not really until we get into the end of the year, start of the new year, that the monsoon starts to kick in. And with the monsoon, we have a couple of different phases. So when it's really raging, we have a monsoon trough over Northern Australia, drawing those winds in from further north, and that's where we get the really heavy rainfall. And as I said, with the monsoon trough over Northern Australia, not only the widespread rainfall, but a higher chance of tropical cyclone, tropical low activity, a lot of cloud, quite windy. People who've lived through monsoons know it's a distinct change from your normal build-up and even compared to the inactive monsoon, which is the map that's just popped up now. And in that situation, the monsoon trough drifts further north of the continent, or it breaks down. And so we don't have those winds coming all the way down from the Northern Hemisphere. And we go back to more like a build-up sort of situation with isolated showers and thunderstorms. So while the wet season itself goes from October to the end of April, the official Australian tropical cyclone season starts at the beginning of November and goes through to April. So we're in both of those seasons now, the wet season and the tropical cyclone season across Northern Australia. So with that, I will hand over to Dean now, who will give you a bit of a look at what happened last season.
Thanks for that, Greg. I'll cover very briefly where it was wet, because it was mainly dry. The second dot point is really what I'm going to cover in the next few slides, and that's the state of the water storages across Northern Australia. And to do that, I'll compare to previous years just to put it into context. Greg, I'll start with the overall picture of storage levels in the three main drainage divisions across Northern Australia. And these are often shown in Bureau presentations to indicate the health of water resources. So if you look at one of the graphs there, there's a bucket that has water in it. That indicates the current storage levels across those drainage divisions, or at least as of 1st of November. The Timor Sea drainage division, that's sitting at about 28% full. It's been dropping the last few years, as you can see. The Carpentaria drainage division, that seems to be pretty stable. So I'm showing here the last 5 years of storage level data on these graphs. And then you've got the North East Coast drainage division, which has slightly been dropping over the last few years as well. I'm not really going to dwell on these pictures that much, except I'll probably highlight two things. One is that you can see that across Northern Australia, storage levels tend to rise after January. And so that aligns with the monsoon period. So you get these rises in storage levels throughout January, February, and as of about March, April, they're dropping. So basically storage levels are dropping for 9, 10 months of the year. The second thing I'll highlight with this is we should treat these drainage division storage maps or storage graphs with some caution. For example, the Gulf of Carpentaria drainage division, that only has one storage. It's only representing the Julius Dam near Mount Isa, which happened to have relatively good rainfall the last couple of years. And then you've got the North East Coast drainage division, which includes about 70 storages, but it's the entire North East Coast as far down as the Brisbane or the South East Queensland storages. So it actually doesn't just include Northern Australia storages. So I prefer to focus on some of the key agricultural water use areas across the region to tell a better story. So we'll look at the Ord region in WA, the Daly region in the NT, and the Fitzroy region in Queensland. And all three of these are important agricultural areas in Northern Australia. And right now, the current storage levels in these regions are pretty dire. And this is largely to do with the poor wet seasons over the last 2 years. So I've got a map there of rainfall decile map of 2 years between July 2018 and June 2020. There's a lot of red across the map, which indicates generally very much below average rainfall the last 2 years. For example, in the Ord region, the rainfall over the last 2 wet seasons has been the driest 24-month period since 1969-71. In the Daly, it's the driest since 1960-62. And in the Fitzroy region, it's the driest 2-year period in more than 100 years. So, it's been a very dry 2 years across Northern Australia. And as you'd expect, this rainfall has had a large impact on the storage levels in these regions. In the Ord region, the primary storage is Lake Argyle. So the photo in the top right, that's taken at the Ord River Dam Wall, which forms Lake Argyle. And it's actually the biggest reservoir in mainland Australia. I think the capacity is a little over 10,000 gigalitres. The graphs are similar to the ones I showed just previously. The bucket on the right-hand side represents the current storage levels, or the storage levels as of last week. And then I'm also showing the previous 10 years of data as that white line there. So as of last week, the storage in Lake Argyle is 29% full. That's the lowest it's been since 1993, so almost 30 years. But just to emphasise, if you look at some of the storage level data since 2010, I'll re-emphasise the point I made in the first slide, and that is that the storage level generally increases in January to March, so during that monsoon period. And the levels increase, or the levels actually regularly fill and spill. So that's where the storage levels go above 100%. And that happens pretty often. And then the levels recede during the remainder of the year. I've highlighted in blue the last 3 years, and you can see the last 3 years, there hasn't been any of that fill and spill. In fact, there's almost been no inflow into Lake Argyle for 3 years running. And this is why the storages are so low at the moment. In the Fitzroy region, the story is actually even worse. The primary storage in the Fitzroy region is the Lake Marraboon, and that is formed by Fairbairn Dam, which is where the photo was taken. There's about 14 reservoirs in the Fitzroy region, but the Lake Marraboon makes up about 80% of the storage capacity of the region. So it's the major storage in the area. Similar to the Lake Argyle, the bucket shows that right now, or as of last week, we're sitting at 9% full in the lake, and this is the lowest on record. So Lake Marraboon was built in the early 70s. It has never been this low. Again, I'm highlighting the last 3 years of storage level data, and similar to Lake Argyle, the inflows during the last 3 wet seasons have been really low, and that's contributing to the low storage levels we currently have. I'll indicate I've got a blue arrow there between 2012 and 2014, and that's where we saw a drop from about 100% full in the lake to about 50% over that 3-year period. And then over the next few years after that, the storage levels hovered around 40 to 50%, and then it dropped away again in the last 3 years. So it looks like this part of Northern Australia has had a sustained period of relatively poor rain. And I'm not sure how far it will go if we have another below average wet season. So it'll be interesting. The final region I'll look at is the Daly region. The key water storage in this region is not a reservoir, but it's an aquifer. And so this region is highly groundwater dependent. The photo in the top right corner, that's the Daly River. It's actually one of the few perennial river systems in Northern Australia. And one of the reasons the river flows all year is because of the groundwater discharge from the 2 main aquifers, including the Tyndall limestone. And that provides the dry season flow in the river. So if we look at the level graph, right now, the levels are, in this particular bore, the levels are below 6 metres below the ground, or below the surface. That's the lowest it's been in more than 20 years. And I'm highlighting the last 2 years on that graph with that orange shading. And you can see during the last 2 wet seasons, there's almost been no recharge into the aquifer. It's almost been continual discharge. So the storage levels previously actually look very similar to the Lake Argyle in terms of you get a recharge into the aquifer during that January-February period, and then you get the recession or the groundwater discharge throughout the remainder of the year. I'm going to highlight 3 years between 2012 and 2015 with that blue arrow. Just show that those particular wet seasons, there was still good recharge into the aquifer. So we're still getting that 2 to 4 metres of recharge. And the annual rainfall in those years was actually close to average. Despite that, over that 3-year period, aquifer levels were dropping during the dry season. And the reason for that is that instead of the wet season generally finishing in April, the wet season in those 3 years finished in February. So instead of, say, 7 or 8 months of groundwater discharge, we were getting an extra 2 months on top of that. So the dry season aquifer levels were dropping despite the fact annual rainfall during those years was close to average. It's just something to bear in mind. In terms of most regions across Northern Australia, the last 2 years has been very dry, and the storage levels, both reservoir and aquifer, are now at their lowest levels in many years. So I'll finish there. Greg?
Just before Greg jumps in, we've got about 6 minutes until our first question and answer session. So if you do have any questions there, please start putting them in now, and we will get them to it. If it's either about water storage stuff that, or anything to do with water that Dean can talk to, or Greg, who is our climate driver expert. So please start sending them in now, and we will get to them as soon as possible. There is just one question that has come through from Lance, and it's a geography question. Where does Northern Australia technically start or stop? Do either of you have the answer to that?
Yeah, I can give you a broad answer as far as the Bureau's analyses go. We normally take Northern Australia as north of 26 degrees south. So that's pretty much the Northern Territory's South Australia border. So we need to take it all with a bit of grain of salt. That's a technical definition. Obviously, then you've got the tropics, which is north of about 23.5. So that's about Rockhampton sort of latitude. And then oftentimes when we're talking about monsoon, that affects parts even further north. So, you know, like the Northern Kimberley, top end of the NT, as well as far north Queensland. That's some technical info anyway.
There you go, Lance. A great question. If you want to get an answer to any question like that as well, just click the chat function. It's in the bottom right-hand corner. It will go blue once it's on, and you can start sending it through. Sorry to interrupt. Take it away.
Oh, sorry, Jordan. I just add something to that too, because in terms of hydrology, they don't necessarily look at a line across Australia and say that's Northern Australia. Often, Northern Australia is defined by the drainage basins, such as the Timor Sea and the Gulf of Carpentaria and the top of the northeast coast. So there are actually different definitions of Northern Australia. It depends who you're talking to.
Yeah, that's a good point. I mean, people will know that, you know, rainfall differs hugely from coastal zones to inland zones, even at similar latitudes. So, yeah, it's there's certainly no black and white answer there. Okay, so following on from what Dean said, we've seen that it's been quite dry over Northern Australia, particularly these last 2 or 3 years. We've had 2 very poor wet seasons as far as total rainfall. So we're going to spend a bit of time on climate drivers because they can give us a pretty good idea about what we're likely to see in the coming months as far as the weather impacts, so rainfall and temperature also. So a climate driver broadly is something that influences the weather on typically a time scale of weeks to months or even beyond that. So the classic climate driver for the world's weather is the sun, but you know that happens obviously all the time, but depending on where the sun is, that will change the seasons. But what we want to look at is drivers that have an influence at particular times of the year, and obviously talking about the wet season. So we're going to spend a bit of time looking at the climate drivers related to something that's called the El Nino Southern Oscillation, which we touched on earlier. So as you can see in the heading here, we're going to look at La Nina, which is one of the phases of the El Nino Southern Oscillation, and it's something that's actually active at the moment. We'll talk about that a little bit more. But more importantly, what does that actually mean to weather impacts and weather elements such as rainfall, temperature, and water storages? So that's what we'll spend the bulk of our time on for the rest of the webinar. So the El Nino Southern Oscillation. So probably the first picture to look at is on the right-hand side, and this is a schematic of what we see in a La Nina situation. El Nino Southern Oscillation is a natural cycle. It oscillates between 3 different phases. So we have a neutral when we're in a sort of the average state, but every 2 to 7 years, it's not really regular, but it happens sort of, you know, every few years. We see changes mainly in, first off, the water temperature pattern across the Pacific Ocean, and it can either go into El Nino or La Nina. They're the 2 other states. So the picture we have here on the right, as I said, is La Nina, and what we see in this situation is that a big patch of cooler than normal water develops around the Central Pacific and towards South America. So you can see that with the blue colours there. At the same time, over Australia and the area to the north of us, which is called the Maritime Continent, we see a build-up of warm water. So the warm water in itself encourages convection or upward motion in the atmosphere and cloud formation leading to rainfall, but it also has an influence on the atmosphere that lies over it. And so that's where that grey arrow going around fits in. So when a La Nina is well developed, or an El Nino, which is just almost the opposite pattern, where we see warmer water over the Pacific and relatively cool waters around Australia, we actually see changes in the atmospheric pattern. And so that's why when we know that we've moved into a particular climate state, be it La Nina or El Nino, we can say broad things like it's going to be wetter than average the next few months over such and such an area. And you can see with that graph there, that in a La Nina, we see increased rainfall because we see more cloud development over the Australian region. So that's what happens in a theoretical sense. If we go to the left-hand side now, we're looking at a map of analyses of, or observations of, what's happening across the oceans right now. And we can see we've got a patch of those blue waters over the Pacific, so they're cooler than average waters. And likewise, we're seeing warmer waters, which is indicated by those redder colours around Australia. So on top of sea surface temperatures, we look at other indicators in the atmosphere to see whether we've got cooler waters below the surface of the ocean. We're also looking at what's happening in the atmosphere. And basically all these things are happening at the moment. And so the Bureau has declared a La Nina event. So we exceeded the La Nina thresholds in about September. And so we're currently in a La Nina, and the modelling that we use and the observations we have suggest it's likely to persist right through till summer. So at this stage, through until at least the end of February. So while that is happening, there is an increased likelihood of above average rainfall across northern Australia. So yeah, that graph up there is, we go through different phases of our outlook, and we're currently at the maximum phase, or a La Nina phase, indicating that an event is currently underway at the moment. So this is an historical composite of various years where we have seen La Nina. And just looking at the map on the left-hand side, it's of rainfall that's happened during 14 previous La Nina events over Australia. And in this case, where the bluer colours indicate above average rainfall. So for the period from October to April, the official definition of the wet season period, you can see that it's dominated by those green and bluer colours. So historically, we see more rainfall over most of Australia, particularly eastern Australia and parts of northern Australia during the La Nina years. Similarly, we can analyse temperature. So we've got maximum temperature on the right-hand side. And in this case, the blue colours are indicating below average temperatures. So you can see quite a strong signal, particularly over Queensland, but much of northern Australia has significantly below average maximum temperatures during La Nina years. And then finally, down the bottom, we have minimum temperature. And we can see there's still a trend towards below average minimum temperatures. It's not as strong. But anyway, putting those maps together, again, like we said, when we're in a particular climate state, or a particular climate driver is active, it gives us a good clue that we're likely to see particular weather elements. And in this case, above average rainfall, below average maximum temperatures, and marginally below average minimum temperatures. In the little infographic box on the right-hand side, just a bit more information, and this is again is all associated with La Nina historically, as well as what the models and the theory tell us. We normally see more tropical cyclones and tropical lows. With the extra rainfall, the potential there is for more flooding than usual. And there's a few other things they're not so applicable to northern Australia. I guess one other thing that is quite interesting for Western Australia is we often see these things called Indian Ocean heat waves, and they often lead to bleaching and marine heat waves around the Northwest Cape across northern Australia. So when we're in La Nina, we can say with some degree of confidence that we're likely to see these particular weather impacts.
Excellent. work there, Greg. We do have a ton of questions coming through, so if we can speed up just a little bit so we can get to your questions, that would be awesome. Sorry to interrupt.
No problem. So people are probably wondering about how the current La Nina compares with historical La Ninas. And the most significant one we've had in recent years happened between 2010 and 2012. So there were two events, and the one on the left was the strongest event. So 2010 to 2011, we saw widespread flooding over parts of eastern Australia in particular, but you can see a very strong signal for above average rainfall. And I won't go into what happened the following year. It was a weaker event, but the 2010-2011 event was the one where there was significant flooding over Brisbane and southeast Queensland in particular, but it was also near record rainfall over much of far northern Australia. What's interesting is that there's usually a relationship between the strength of a La Nina and its impact. So this was one of the strongest La Ninas on record based on the sea surface temperatures, as well as some of the indicators of the atmospheric circulation. And hence we had these very strong impacts. The current event is a bit different. It started a bit later and it's certainly not as strong at the moment, but some of the modelling suggests it could be a significant event, may peak at a strength comparable to that 2010 La Nina, in which case there's the potential for some significant impacts as we get later into the season and into early 2021. So just quickly, a quick little snapshot of sea surface temperature patterns for the two different events. So on the left-hand side is the current event. We've seen that there's some cool waters around the Central Pacific where that box is. But if you look on the right-hand side, you can see just how much more cold water there was, and again, indicating a stronger La Nina back in 2010. Similarly, the warmer waters around Northern Australia weren't as pronounced in 2020 as they were back in 2010. So for a summary, for climate influences, the ENSO, or the El Nino Southern Oscillation, is the main seasonal climate driver we look at and has a significant impact on Northern Australia. It's underway at the moment. We have the cooler waters across the Pacific Ocean, warmer waters around Australia. All the guidance we have at the moment suggests that it's likely to last until at least February 2021, which means the impacts will continue at least till that long. And it could also potentially be of comparable strength to the significant event of 2010-2011. And we've talked about the fact that we often see above average wet season rainfall across Northern Australia. It's typically associated with an earlier onset of the Australian monsoon. And we also see more tropical cyclones and lows during La Nina years. I think with that, we'll hand over to Dean, unless Jordan wants to pop in some questions now.
Yeah, we might jump into some questions because we do have a few that are coming in. So I'll jump into one, and then Dean, you can finish your part, and then we'll get to the proper question and answer time. But this is actually a question for Dean. You were speaking before about the Fitzroy region. So Ash has asked, in regards to storage levels in southeast Queensland, are we seeing them dropping year on year, like, for instance, in Fitzroy?
That's a good question. For southeast Queensland, it's this is getting to the definition of Northern Australia again. In strictly speaking, it's not how I define Northern Australia. But however, I'm just very quickly looking at we've got a storage website on the Bureau website. I'm really quickly having a look at what's happened. You're right. It has been dropping the last 5 or 6 years. There's been a steady decrease in storage levels around southeast Queensland, not to the same extent as further north, such as Lake Argyle and Fitzroy and the Burdekin region. So storage levels have been trending lower, certainly the last 5 or 6 years.
Okay, great. Well, you take it away, Dean, and quickly we'll jump to our question and answer session.
All right. Well, similar to Greg, I think the best indication of what we might expect to see in this upcoming wet season is looking at historical data and what happened to water storages in previous La Nina years. So I'm going to the Ord region here. This is a graph of 50 years of annual flow data in the Ord River. Now, the Ord River is one of the primary tributaries that feed or inflow into Lake Argyle. I've indicated in blue the annual flows that were impacted by a La Nina year, and orange are annual flows that were occurred during an El Nino year. And the yellow line across that graph is the average flow over that 50-year time period. So from this graph, and it will come as no surprise, but annual flows in La Nina years tend to be above average. And the highest annual flows that have occurred in the Ord River occurred during La Nina years. And flowing in El Nino years tend to be lower than average. So that's actually a typical pattern for river systems across most of Northern Australia. How the streamflow pattern translates to storage levels, again, I'm going to look at those three key agricultural regions. I'll start with the Ord. This is storage levels in Lake Argyle for the last 25 years. I could show the entire period of record, but it's actually difficult to see what's going on. So this 25-year time period reflects the entire period of record anyway. I'm highlighting on this graph in blue the periods where we had La Nina years. And so the light blue are the moderate to strong La Nina years, and the darker blue periods that you see in 2008 and 2009, they're of the weaker La Nina periods. You can see that in general, particularly during the moderate and strong La Nina years, storage levels tend to increase. And they've also resulted in some very high flows as well in terms of fill and spill, so well above 100% storage levels during the wet season. And even in the weak La Ninas, they've resulted in greater than 100% storage levels during the year. So, based on recent history, we should expect a higher rise in levels certainly compared to the last 3 years. As to seeing whether the reservoir will fill and spill this year, no, not so sure. And that's particularly given the low starting point we're at right now. If we look at the Fitzroy region, again, these are the storage levels in Lake Maribyrnong in the Fitzroy region over the past 24 years. Again, I'm highlighting the periods of time where we were affected by La Nina. And you can see that in general, during the La Nina periods, storage levels were relatively high, particularly that 2010 to 2012 period that Greg mentioned. That was our last really strong La Nina. Probably almost for the entire 2-year period, the Lake Maribyrnong was hovering around 100% full. As to this year, again, we're starting from that really low base. We're only at 9% full here at the moment, but we can expect a higher rise in levels compared to the last 3 years. The final region, the Daly region, this is the storage levels over the last 25 years or so in the Tyndall limestone aquifer. Again, I'm highlighting the La Nina periods in the blue, and although there's missing data in 1999, you can see in general during La Nina years we'll get a rise in aquifer levels. Even during the weaker La Nina periods, there's this rise in aquifer levels throughout the year. So I guess the underlying message across these regions is that we can expect a rise in levels this year. What will be of real interest is to the extent, given the low levels we're currently at. And so much will depend on where the large tropical low systems form and their travel path, which unfortunately Greg can't help us out with yet.
All right, fantastic, guys. We do have time for Q&A right now, so we're going to get to as many as we can. Don't forget, you can keep sending them in. Hit the chat button. It will go blue once it's on, and you can drop in your question. Now, we do have a question that's coming from John. I think this would be best for, actually it might be best for both of you. Let's see. John is saying, are we expecting an increased recharge for the coming wet season due to La Nina?
Did you want me to start that?
Yeah,
Greg?
you have a go, Dean. Yeah, sounds more up your alley.
Well, in terms of the aquifers, if we're talking recharge into aquifers. Based on historical data, we should expect recharge into the aquifers, certainly more recharge that has been going on the last 2 or 3 years. I'm quite familiar with the aquifers around Katherine in the Daly region, as well as the rural area of Darwin. Those aquifers have been dropping the last few years. There hasn't been a lot of recharge, but what we've seen based on historical data is that we can expect a rise this year that's greater than what we've seen in recent history.
Okay, now we move to Eileen, who's asked, and I think Greg would be the best person to ask for this, and you might have touched on it quickly, but are we expecting the current La Nina to trail off after Feb 2001? And when will we know if it's going to trail off or not?
Yeah, so La Nina and El Ninos, for that instance, normally do start easing off as we get into the end of the summer period. So we would normally expect to do that. However, we have seen some model guidance suggesting it could be quite strong during the December to January period, in which case it might take a little bit longer to trail off. So there's some indications that it could even persist into March, but it should be weakening at that stage as well, which it normally does, just part of its natural cycle.
Okay. Ken has asked a really interesting question of you, Dean. We often hear from MPs saying more dams. Would this actually help with water storage?
Wow. Okay. That's a politically sensitive question. If we're talking Northern Australia, that's more difficult. And part of the reason we have so few reservoirs in Northern Australia is that the evaporation is just so high. So I know that CSIRO did a study a few years ago about that very question, about whether we can have more reservoirs in Northern Australia, and they actually said it's very difficult. For example, the evaporation in Lake Argyle is just it's close to 4,000 to 6,000 gigalitres a year. It's an incredible amount of evaporation loss during the year. The other thing is also the places where you can contain a reservoir. Obviously, you can't have them near the coast. They have to be more inland. And of course, the further inland you go, the less rainfall. So there's a few interesting little reasons why we don't have. Yeah,
there's no real straight answer for that, so I'm sorry about that, Ken. A bit of an easier one for you. Miranda has asked, do you have a catchment by catchment estimates, like website or something that people can visit?
For storages, if it's for storages, yes, we do have a storage website on the Bureau pages, and it shows the storages based on capital cities, or for us, for Northern Australia, it will show storage levels by drainage division. And then from there, you can also click on individual storages.
Yeah, so nothing in the way of estimates?
Nothing in terms of future estimates?
Yeah, well, I mean, I'm guessing that's what's in the question.
No, we have, as far as we go, we have stream flow estimates. So you can draw parallels to that, but that's as far as we go at this stage.
Okay, great. Very quick answer from you, Greg, and then jump into your part of the presentation. Yes or no? Elizabeth wants to know, was the 2017 Cyclone Debbie during a La Nina season?
Probably not. Can't say straight yes or no. It was, some agencies suggest it was a very weak La Nina. The Bureau suggests it didn't quite reach our threshold. So I'd say from an Australian perspective, no.
Okay, fantastic. Well, excellent questions, and we have a ton to get through. So I'm going to give it back to the guys so they can start talking about something that we are getting a bulk of questions about, some cyclones. So I'm sure, Greg, you're going to talk about that in just a little bit. Take it away.
We will. Okay, so we're going to have a look at what's happening in the future. So we've talked pretty much about what's happened in the past now, and we're going to look at rainfall and temperature in particular, flood risk, and also tropical cyclone risk as well for the remainder of this wet season. So here are some rainfall outlook maps. So there's 3 different periods here. On the left, we have just for the month of December. Then we have the season, full summer season, December to February. And then we're going towards the second half of the wet season on the right-hand side, January to March. And I guess the take-home message is that we have a lot of blue and green colour, so indicating greater than 60% chance of above median rainfall. You can see certainly once we go beyond December, the strongest signals are over Queensland. And as Dean mentioned with that Fitzroy catchment, that would be very nice if we did see some significant totals associated with those outlooks over that area and make a good stint at recharging and really increasing the outflows. But for the most part, right across Northern Australia, there's a pretty significant chance of above median rainfall. And that's a typical La Nina pattern. And certainly all the modelling from Australia as well as other international agencies are suggesting that particular type of picture. Just quickly on temperature, so we've got just for the 3 months from December to February, maximum temperature on the left, minimum temperature on the right. And the maximum temperature, again, for the most part, is suggesting average to below average, and that goes along with the rainfall. So if we're expecting to have more rainfall, that means we're going to have more cloud around, more moisture in the atmosphere. That will just put a lid on the really hot days, and so a good chance of just seeing close to average. There's some places like at the far North Cape may see above average temperatures. The tropical coast as well of Queensland, there's a good chance to see above average temperatures. Minimum temperatures, however, it's not a pretty picture if you're looking at some cool nights over the next few months. Greater than 80% chance of minimum temperatures right throughout that 3-month period. And over to Dean now.
No worries. Actually, one question that does come up a bit when a La Nina climate system is declared is will we see more floods? In general, you'd think the answer was obvious. More rain, higher stream flows must equal more floods. So I'm going to look at 2 flood warning areas across Northern Australia, one in Katherine and in the NT and one in the Burdekin River near Charters Towers, and just look at what's happened historically in La Nina years. Just out of interest, that photo of Katherine River, that was the last major flood we saw along the Katherine River. That was in 2006, and that's a picture of the main street of the town of Katherine. The Burdekin River photo, that's not far from Charters Towers. That's at Selheim gauging station, and that was during the flood just last year, I think. Yeah, January 2019. Next slide. So we'll look at the Burdekin River. That photo in the top right corner is the Burdekin Falls Dam. It was taken by Rosalind Budd Photography. She takes a whole lot of great photos along the northeast coast of some of these agricultural regions. In the graph, I'm showing, again, a 25-year period, and this is 25 years of stream flow in the Burdekin River at Selheim gauging station near Charters Towers. I've indicated in the blue shading, they're periods of La Nina years, and in the yellow shading, that is the El Nino years. And the yellow dashed lines across there are minor flood level and a major flood level. Two of the three largest floods in La Nina years, sorry, yeah, that's better. The top 3 largest floods occurred actually in La Nina years, and you can see them in 2009 and 2011. Over the 25-year period, there's been 11 floods, and 5 of them have occurred in La Nina years. So we can say, based on historical data, the chance of flooding during a La Nina in this area is probably higher than average, and in many respects, this is what you'd expect. In terms of Katherine, however, I'll just talk about that photo for a minute, because that's a great photo from Sean Lowe, who works at Department of Environment and Natural Resources. This is a photo of the Katherine Gorge, or Katherine River upstream of the gorge. It was taken in the last major flood in 2006. Many of you might be familiar with this region, the Katherine Gorge region. You can, during the dry season, you can swim and kayak up that river. And when you're in that gorge, the escarpment or the walls of that river are about 30 to 50 metres high. During this particular flood, it was almost full. So that gives you some context of how much water was flowing down this river in a major flood. in terms of the last 25 years, there's been 5 floods. The 2 biggest, or the 2 major floods in Katherine River didn't actually occur in La Nina years. In fact, the largest flood in 1998 was an El Nino year. So, and then the second largest was a neutral year. So in terms of floods in La Nina years, there's been one. There's been one flood in a La Nina year. So in this case, based on historical data, the chance of a flood during a La Nina year is probably about average. It doesn't necessarily increase. I was actually relatively surprised at this result. So I looked at another flood warning area in the Northern Territory, the Adelaide River, and the same thing happened there. So we probably need to look at this further, but certainly in the Queensland part of Northern Australia, the risk of flooding does increase in a La Nina year, less so in the top end.
That's really interesting, Dean, and it probably segues well into what I'm about to talk about now, because I know particularly that 1998 flood in Katherine was caused by an ex-tropical cyclone. So often it's going to be those really intense events that can happen in El Nino, La Nina, or any years that can lead to that. But that's another discussion that Dean might look into one day. But we'll go into tropical cyclones now in general. As I said earlier, we're in the tropical cyclone season now, which runs from November to the end of April. And no matter what climate state you're in, La Nina, El Nino, positive or negative Indian Ocean dipole, these are always a risk for Northern Australia, particularly coastal parts of Northern Australia. So we've obviously got hazards associated with winds, and we've got just a quick little schematic there talking about the category system that we use, with category 1 of the lesser winds, still gale force winds with gusts up to about 124 kilometres an hour, going right up to the category 5 winds, and you can have wind gusts in excess of 300 kilometres an hour, which will basically rip even a well-developed house apart potentially. There's other things or other impacts associated with tropical cyclones. Down the bottom left, there's a bit of a picture there of storm surge, and the action of the winds, plus also the very low pressure associated with the centre of a tropical cyclone, causes a bulge of water to form and track along with that tropical cyclone. And if that cyclone moves onto a coast, it carries that water inland with it and can raise the water well above the highest astronomical tide and potentially several metres above that. And historically, across the world, storm surge is associated with the greatest number of fatalities as far as anything to do with tropical cyclone events. And even in Australia, we've seen storm surges in excess of 8 metres above the highest astronomical tide. So they can be particularly dangerous for coastal people. But going back to what Dean's been talking about, and floods in particular, they are always an issue with tropical cyclones, or tropical lows, and they can be major rainfall producers, and hence with extreme rainfall over a small area, flooding can certainly be an issue. And it really doesn't matter how strong those cyclones or lows are. Weak tropical cyclones or ex-tropical cyclones, or even just tropical lows, can be major rain producers and generate hundreds of millimetres of rainfall in 24-hour period. So the outlook that the Bureau releases each year is consistent again with what we've been saying about above average chance of tropical cyclones during La Nina years. At this stage, across Australia, we're likely to see a 66% chance of greater than average, and the average number is around 11 tropical cyclones a year. So all parts of Australia that see tropical cyclones have a greater than 50% chance of seeing more than their average number in this particular season. The other thing with La Nina is often the first tropical cyclone of the season develops earlier than normal, as early as mid-December or early December. And with that earlier tropical cyclone forming, the first landfalling tropical cyclone typically happens earlier in La Nina years as well. And of interest for the people in Queensland, the only times that we have had more than one tropical cyclone impacting Queensland coast is during La Nina years. For the upcoming season, this is a list of the names that we will be running through. So any cyclones that form in the Australian region this season will have one of these names. The first cab off the rank will be Imogen, and then we'll go through the alphabet after that. So these are the names that we're likely to see if we get enough cyclones. So that's up to 12 cyclones. So if we get that above average cyclone number, we could end up with a Vernon at some stage over the course of this season. Back to you, Jordan.
Excellent. Thank you so much, guys. We are going to be a little bit late today with the end because we do have a lot of questions that we'd love to get to. So let's start firing into them. Why has it been so hot in Darwin recently? When will we get a break?
Yes, I'm sure that's a very good question for a lot of the long-suffering people in far northern Australia. And that's a combination of a few factors. Obviously, there's been not much rain around at all just lately. The wind patterns as well have been conducive to hot temperatures, and we've also got global warming on top of that. So we've seen significant warming in recent years across northern Australia. There are some hints, though, in the weather patterns and the model guidance that we have that we could see a change in weather developing across northern Australia in the first or second week of December. So it looks like we do have a pulse of that Madden-Julian oscillation is potentially going to move into a region that will be favourable for above average rainfall and could even set off the monsoon at Darwin sometime in the first half of December. So a lot of people in Darwin in particular will know that how much of a difference that can make to the temperatures and the conditions there. So we'll just keep our fingers crossed that that actually does have that desired outcome.
All right, Damien wants to know, what is your forecast for tropical cyclone? And you just spoke about it, monsoon low activity in the Gulf of Carpentaria.
Yeah, so similar to all regions across Australia, it's very hard to say where a cyclone is going to form. Really, our forecast is skillful when we look at the whole region, but we would expect to see an above average number of cyclones right across the eastern region and the northern region, which includes the Gulf of Carpentaria. So we'd expect to see a bit more than the average number. So we normally in Northern Territory see 2 to 3 cyclones in an average year and about 4 cyclones over Queensland. So at this stage, looking at those sort of numbers and potentially more.
All right, staying with cyclones for 500, Maya wants to know, is there a specific time period when we can expect to get the tropical cyclone, when the tropical cyclone would hit this year?
Yep, so if that pulse of the Madden-Julian oscillation does keep moving closer towards Australia, we could see something even in the next couple of weeks in Western Australia. We actually saw the first Southern Hemisphere tropical cyclone of the year develop just in the last week in the central Indian Ocean. And as that Madden-Julian oscillation pulse moves towards Australia, which it's forecast to do, we could see some activity develop closer to Indonesia and off the Indian Ocean off the northwest coast of Australia. But typically in a La Nina year, we normally see the first cyclone in the Australian region in the first week or so of December.
Okay, Shani would like to know, what are the chances of a similar event this year as there was last year with the far north Queensland monsoon, which had, the problems with Cooktown and Townsville and then inland draining into the Gulf? Can we see a repeat of that?
The monsoon is very fickle, but certainly you would think we're going to see some probably more monsoon activity than what we did last year. The monsoon was really a problem last year because it sat in the one place for a long time. So a lot of things have got to come together, and we certainly can't forecast something like that. But there's a good chance that we're going to see above average monsoonal activity in the coming months. And so there will be some places who will see some very heavy rainfall, tropical cyclones and tropical lows develop on that monsoon trough. And areas are likely to see, flooding and widespread rainfall.
Okay, so we're going to get to our last question now. We are going to run a little bit late, but if you can stay by, it's worth it because we have some really good information coming up after this last question. Ian would like to know, and I think this is perfect for you, Dean, water storage time series since 2017. We had an IOD in 2019. What were the drivers in 17 and 18? If you can think about that off the top of your head.
That's a really good question. Because in 17-18, so that 17-18 wet season, it was a neutral year, so there was no real strong climate drivers. The annual rainfall across most of northern Australia, certainly in the Ord and the Daly, the annual rainfall was close to average too. The issue with storage levels during that year, however, was the early finish. That was the main thing. And so instead of the wet season finishing in April, it finishes in February, then you've got a longer period of time of evaporation. So instead of a 6-month dry season, you've got an 8 or 9 month dry season. So that was the big issue in 2017-18 across northern Australia.
Okay, excellent. Well, unfortunately, that's all the time we have for 4 questions. But Greg, you've got some great information to pass on to us, and also a place where you can email us your questions if we didn't get to it today.
Sure. So very quickly, just the summary, take-home messages: above average rainfall likely in the coming wet season, earlier start to the monsoon, above average flows in the river is likely during La Nina. Similarly, increase in storage levels, certainly compared to the dry last couple of years. Flooding, again, it's going to vary from place to place, but overall, La Nina sort of increases marginally the chance of certainly widespread rainfall and the potential for flooding. And we've talked about an average to above average number of tropical lows and cyclones in the coming months. So we have a whole list here of places where you can get extra information. There's climate information, tropical specific information in there, as well as a lot of water data, stream flow forecasts and analyses. And there's also some videos in there. So a whole bunch of information for people to look at.
Awesome, excellent. And that's going to be with your email. Anybody who has attended this, they will get an email, or registered, excuse me, you'll get an email that will have all of this information in it, and the presentation materials, and also the video of today. So that does bring us to the end of the webinar. But if you'd like to get more Bureau information on your favorite platform, why not connect with us on social media, our blog, our BOM blog, or our excellent BOM weather app. You can subscribe to recent updates direct to your inbox from the Bureau on everything that Greg and Dean have talked about today, or information on upcoming webinars. Speaking of which, we do have one that will focus on our next season, summer. We put a lot of effort into our change of season webinars to give you the information you'll need for the upcoming months ahead. So put this one in your diary now. Summer 2020 Climate and Water Update will be on the 3rd of December. If you'd like to come along, then click the link in the registration link in the chat now so you can join us. And that brings us to the end of today's webinar. For the questions we didn't get to, please email us, helpdesk.climate@bom.gov.au. A big thank you to Greg and Dean. We appreciate your time in developing the content and sharing your knowledge with us. And to you, thank you for tuning in and joining us today. We hope you enjoyed this session, and we do hope you'll join us again next time. If you'd like to continue the conversation, please use the hashtag BOMWebinar in your social media posts. As mentioned earlier, this session has been recorded, and we will have the video ready for you soon, so watch your inbox. And finally, but most importantly, we want your feedback. It's our aim to bring you the highest possible quality webinars, but we can't do that unless you share your experiences with us. Once we close this webinar, a short survey will pop up on your screen, and we'd be very grateful if you could complete that anonymously for us. Once again, thank you for your time. We look forward to seeing you again soon. Goodbye.